ESS Atmospheric Systems and Pollution Management Part 7 will examine the pollution problem known as acidic deposition, rain, snow, or particles. Acid deposition is a troposphere pollution problem that results from burning fossil fuels. Toward the end of this movie, we will evaluate methods to reduce acid deposition. The significant ideas are acid deposition can impact living systems and the built environment. The pollution management of acid deposition often involves cross-border issues. And lastly, pollution management strategies can be applied at different levels. Here is the outline of all the available movies in the unit called Atmospheric Systems and Pollution Management. Use this outline to find the movie you need for review. This movie is focused here. Acid deposition is a pollution problem involving two different acids that are secondary pollutants resulting from the combustion of fossil fuels. Acid deposition is a regional pollution problem affecting areas downwind from industrial centers that burn fossil fuels. But acid deposition has crossed from one country into another, resulting in international disagreements. Here are two IB syllabus statements that I've covered before but have relevance here. Most reactions connected to living things occur in the inner layers of the atmosphere, the troposphere, and the stratosphere. Human activities change the concentration of atmospheric gases such as ozone, carbon dioxide, and water vapor, which have significant effects on ecosystems. The combustion of fossil fuels releases sulfur dioxide and nitrogen oxides as primary pollutants. These molecules are transformed into the secondary pollutants, nitric acid and sulfuric acid, that we generally call acid deposition. Rain, snow, or dry particles can fall to Earth as acid deposition. Acid rain is one form, probably the most prevalent form, of acid deposition, and its effects can be seen as direct damage to the needles of the conifer trees in this forest. Sulfur dioxide or nitrogen oxides are emitted to the atmosphere as primary pollutants, where they mix with water to form an acid. In this example, sulfuric acid, a secondary pollutant. Sulfur dioxides can often be traced to specific coal-burning smokestacks, making acid rain a point source pollution. Before going any farther, let's define acid deposition as precipitation, wet or dry, that is significantly more acidic than the natural pH of rainfall at 5.6. That's right, rainfall is naturally acidic at 5.6. Acid rain needs to be significantly more acidic than 5.6 to be considered a pollution problem. This diagram displays the process leading to acidic deposition. Sulfur dioxide and nitrogen oxides are released into the air as primary pollutants from an industrial area burning fossil fuels, often coal. The sulfur dioxides and nitrogen oxides are moved by the wind, where they mix with water and then precipitate as acidic precipitation, acidic deposition, downwind of the industrial area, possibly crossing international boundaries. The point source nature of the primary pollutants result in international disagreements over acid rain. You can see in this image that acidic precipitation damages plants, lakes, and marble statues. Industrial smokestacks are built to release pollutants up high so that they blow away from the immediate area. No one wants pollutants, so we push them up high so that they are out of sight and the wind takes them far away as possible. While we all depend on energy, no one wants an industrial complex like this in their backyard. Not in my backyard. Here's our first IB syllabus statement of significance. Describe the formation of acidified precipitations, including the following events. Combustion of fossil fuels produces primary pollutants, sulfur dioxide and nitrogen oxides. Sulfur dioxide and nitrogen oxides are transformed into secondary pollutants of acidic dry deposition or acidic wet deposition. Let's look first at the two acids which form the bulk of acidified precipitations: sulfuric acid, H2SO4, and nitric acid, HNO3. Sulfuric acid is formed from sulfur dioxide mixed with water, and nitric acid is formed from the nitrogen oxides also mixed with water. And truthfully, this is the extent of the chemistry needed to address the syllabus statement on the last slide. You can see the sources of sulfur dioxide here and the sources of nitrogen oxides here. Here's a more detailed look at the chemistry leading to acidified deposition, but you will not be asked to recall these equations. Sulfur dioxide mixed with water leads to sulfuric acid, which dissociates into hydrogen ions, and hydrogen ion concentration defines the term acid. Nitrogen oxides and water leads to nitric acid, which dissociates into hydrogen ions, the acid. Acid precipitation is a regional pollution problem, and here is our next IB syllabus statement. Explain why the effect of acid deposition is regional rather than global. Acidic deposition may cross international boundaries, requiring international cooperation in reducing the pollution. Acid deposition is a regional pollution problem because, first, it requires an industrial center, as shown here. Secondly, only locations downwind of the coal burning are affected. And thirdly, acid rain precipitates. In other words, it washes out of the atmosphere within a few hundred, maybe 1,000 kilometers of the source pollution. On this map, notice the regional nature of acid rain. The areas affected by acidic deposition are in blue, with darker areas receiving a rain of lower pH, more acidic, than the lighter blue areas. Coal burning in the Ohio River Valley here results in regions downwind that receive acid deposition, including Canada. This has resulted in disputes between the US and Canada. Industrial activity along the eastern corridor of the UK, the Manchester area specifically, results in regions downwind receiving acid deposition. But notice that the acid deposition falls to earth just downwind of where the coal is burned, including Norway and Sweden and Finland and parts of Germany. This has resulted in disputes between the UK and other countries in Europe. One last note: local geology also influences the impact of acidic deposition. If the soils can buffer acid deposition, its effect is less. But if the soils cannot buffer the acid, the impact is greater. Both of the regions on this map, here and here, have soils that cannot buffer the acidic precipitation. Thus, the impact of acid deposition has been greater there. On this map of Europe, the lines represent a certain pH, an average value from 1978 to 82. Lower, more acidic pH values are in the center, closest to the coal burning source here in the UK, the Manchester Industrial Centre. Lakes in Scandinavia and forests in Germany and Eastern Europe have been particularly hard hit because soils cannot buffer the acidic deposition. This graph displays sulfur dioxide emissions from 1950 to 1980 and sulfuric acid precipitation from 1950 to 1980. This graph displays a very strong correlation between sulfur dioxide emission in the UK, the red line, and the sulfuric acid precipitation in Scandinavia, the blue line. On this map of Europe, I've added some information on the effects of acidic deposition between 1978 to 1982. Scotland recorded the lowest pH ever for a rainfall at 2.4. Norwegian lakes in a 13,000 square kilometer area have no fish. And 18,000 lakes in Sweden have a pH less than 5.5 for part of the year, and half of those lakes have no fish. Acidified lakes can appear clear and quite beautiful, but the low pH has specific negative effects on various species, something I'll be getting to later in this movie. This is a map of the northeast United States, and it shows a region downwind of coal-burning power plants located along the Ohio River Valley. Here, where I've located the star, the region downwind of the Ohio River Valley has lost about 1.3 million acres of forest. In 2014, President Obama promised to phase out all coal-burning power plants in the U.S. by the year 2030. So here is a relevant IB syllabus statement. Describe 3 possible effects of acid deposition on soil, water, and living organisms, including direct effects: acid directly on aquatic organisms or coniferous forests; indirect effect: increased solubility of metals, particularly aluminum ions, on fish; an indirect effect: nutrient loss due to leaching from the soil. Here you can see the direct effect of acidic deposition. We can see tree death in coniferous forests. By the way, coniferous forests are forests of trees that produce cones, like pine cones, the cones of spruces, or the cones of firs. Here you can see the direct effect of acidic deposition on crops. Acidic conditions, low pH in waters exposed to acidic deposition, cause fish to suffer direct effects. Gills produce excess mucus in response to the low pH, and this causes respiratory problems. Gills become damaged, and the fish are less healthy, and the fish die. Here are examples of direct effects of acidic deposition. You should be taking some notes. There's direct tissue damage to leaves with subsequent leaf loss, reproductive failure due to egg sensitivity to low pH. There are gill problems, mucus buildup which inhibits respiration, and hemoglobin does not carry oxygen in low pH very well. And lastly, crustaceans do not absorb calcium well in low pH, thus they struggle to build their exoskeletons. Now let's look at the indirect effects of acid deposition, including changes in metal solubility, increased solubility of metals, metals that are toxic to living organisms once they are dissolved in solution. This photograph shows the effects of aluminum ions on wheat seedling growth. We have wheat seedling growth under low aluminum concentration on the left and wheat seedling growth under high aluminum concentration on the right. Remember, acidic conditions increase the solubility of aluminum in the soil, especially in locations where the soil cannot buffer the acidic conditions. This photograph displays cotton root growth under conditions of high pH on the left and low pH on the right. Acidic conditions increase aluminum solubility, thus exposing the roots to aluminum ion toxicity. These photographs show the effect of pH on fish and amphibian reproduction, as juveniles do not grow very well under low pH conditions. Low pH in soils and lakes increases aluminum ion solubility in those locations that cannot buffer the acid, and this reduces the reproductive success in fish and amphibians. And lastly, as an indirect effect of acidic deposition is nutrient loss due to leaching. This occurs in locations where the soil cannot buffer the acidic conditions. The leaching of nutrients from the soil makes those nutrients unavailable to plants, and this reduces productivity, NPP, of the plants. Here are images showing the results of leaching due to acidic conditions. Leaching occurs in soils that cannot buffer the acidic deposition. Here are examples of indirect effects of acidic deposition due to the increased solubility of aluminum at low pHs. Aluminum in the soil or lake sediments is more soluble at low pH. This causes damage to fish, trees, and crops. Aluminum is simply toxic to fish above a certain concentration. We have nutrient leaching from the soil, and we have a decline in biodiversity as species composition changes. Here are examples of indirect effects of acidic deposition due to leaching of nutrients from the soil. Nutrient leaching from the soil occurs due to low pH precipitation, plant productivity is reduced, there's a decline in biodiversity as species composition changes. As I've already mentioned, soils can buffer acidic deposition or not, depending on their chemical composition. The chemistry of buffering is here. If soils have calcium carbonate, also known as limestone, the calcium carbonate reacts with the hydrogen ions arriving in the acidic deposition. In turn, the calcium carbonate is transformed into calcium ions and bicarbonate. In other words, the presence of calcium carbonate, limestone, in the soil serves to reduce the impact of acidic deposition. A bit more of the chemistry, the bicarbonate mixes with more hydrogen ions to form carbonic acid, that in turn transforms into carbon dioxide and water. In other words, the limestone is transformed into carbon dioxide and water under the influence of acidic precipitation. The effects of the hydrogen ions of acidic precipitation are mitigated or reduced because of the limestone. Okay, fine. But now consider the impact of acidic deposition on limestone and marble statues in urban areas. I'm addressing this syllabus statement. Acid deposition can impact living systems and the built environment. Marble or limestone monuments are suffering because of acidic deposition. Acid deposition can impact living systems and the built environment. And that brings us to the last IB syllabus statement related to acidic deposition. Describe and evaluate pollution management strategies for acid deposition, including altering human activity to reduce fossil fuels by the use of public transport, walking, cycling, or energy-efficient technologies. Find alternatives to fossil fuel use, such as alternative energy sources. Using catalytic converters or scrubbers to clean the exhaust of primary pollutants from smokestacks or car exhaust. International agreements and lobbying of national governments serve to reduce pollution production. And lastly, cleanup, restoration, recolonization measures, including spreading of limestone on acidified lakes. The first strategy to reduce acid deposition formation would be strategy 1, altering human activity through education, incentives, and penalties, or finding alternative technologies. Choosing energy-efficient technologies such as a fluorescent light, or choosing to change our behavior and turn off lights, use less energy, would be the best strategy, as less pollution occurs and the actions are less costly than cleanup or restoration. However, there are limitations in the efficiency of technologies, and human behavior is often difficult to change without incentives or good education. Carpooling, using public transport, or riding bicycles would also reduce acid deposition, but these forms of transportation are less convenient for workers and may reduce time on the job or reduce quality of life. Changing societal behaviors is not easy, but with incentives and law, strategy 1 is the most effective option for reducing environmental harm and lowering the cost of pollution. Alternative energy sources would reduce the effects of burning fossil fuels and reduce acidic deposition. But for the moment, alternative energies are expensive and not practical in the transportation sector. Alternative energies need to be cheaper, or their use needs to be mandated by law and enforced by law. Alternative energies produce electricity, which is a less practical form of energy for use in automobiles. Another strategy that's important for you to know, a strategy that would reduce acidic deposition, would be to replace coal with natural gas. But I do want you to be thoughtful. Both coal and natural gas are fossil fuels, so both ultimately release carbon dioxide. But coal contains more sulfur, thus contributing to acidic deposition. Natural gas is in essence a cleaner fossil fuel. Because natural gas has no sulfur, and because natural gas releases less CO2 per unit energy, for the purposes of reducing acidic deposition, natural gas would be a better choice, a cleaner choice, than coal. But be thoughtful, very thoughtful on the politics of natural gas, because those who want to continue using fossil fuels as society's primary form of energy promote natural gas as if natural gas is truly green, a truly green form of energy akin to wind power or solar voltaic power. Natural gas is a fossil fuel. CO2 is released, as with all fossil fuels when they're combusted. Imposing a tax on carbon emissions would be a strategy 1 approach toward less fossil fuel use, thus mitigating acid deposition. This would require government intervention, and consumers would pay the cost. Governments can regulate fuel quality. High-quality fuels are cleaner fuels, and they result in fewer primary pollutants that would cause acidic deposition. But higher quality fuels are more expensive. Remember that acid deposition is an international issue simply because of the water cycle. Pollutants rain out of the atmosphere downwind of a source of primary pollutants. Thus, international agreements to reduce fossil fuel use would serve to reduce acidic deposition. This includes the Paris Accords and the Kyoto Protocol, among others. International agreements require compromise and take years to implement. You will hear more about international agreements when we study climate change. Reducing or regulating pollution at the point of emissions, strategy 2, can be done with catalytic converters, seen here, or smokestack scrubbers here, or filters of one sort. These methods are quite effective in removing nitrogen dioxides and sulfur dioxides as pollutants. These forms of technology add cost to the prevention of pollution. They add costs to the consumer, which consumers don't like. This is where government law and enforcement are important. For acid deposition, a strategy 3 method is available for restoring acidified lakes to a higher pH. Spreading lime on the lakes is the strategy. In the photographs here, you can see lakes having calcium carbonate, powdered limestone, lime, being distributed across the lake. The method works to raise the pH of the lake and bring back fish stocks, but the method is temporary. Thus, liming must be done every year or even more frequently. As well, it is costly, and as a strategy 3 approach, remember the environment has already suffered environmental damage, possibly a loss of biodiversity. Spreading lime, calcium carbonate on lakes is a strategy 3 approach to mitigate the impact of acid deposition on lakes. The method works to raise the pH of the lake and bring back fish stocks, but the method is temporary, thus liming must be done every year or more frequently. As well, it is costly, and the environment has already suffered environmental damage, possibly a loss of biodiversity. Restoration, replanting, and restocking serves to return damaged ecosystems to a healthier state. This is a strategy 3 approach. Once the pollution ends, ecosystems can increase their diversity through restoration, replanting, and restocking. The restoration of ecosystems, as seen in this image, is costly and not fully effective as environmental damage has already been done. Here is a summary of the strategy 1 approaches to the mitigation of acid deposition. I've provided general statements here. You need to be specific about actual solutions that are not provided here. Always be specific. I'll let you study this slide on your own, as I've already talked through this material in the slides previous to this one. Here's a second slide summarizing strategy 2 and strategy 3 approaches to the mitigation of acid deposition. I've provided general statements. You need to be specific about actual solutions. Always be specific. Always keep in mind that strategy 1 approaches, altering human behavior through education, incentives, and penalties, as well as using alternative technologies, are the most effective strategies because they limit the release of pollution in the first place. Study this slide on your own. And that brings us to the end of IB ESS Atmospheric Systems and Pollution Management, Part 7.